Hello students, today we are going to discuss about Henry law and its applications. So let us start the session. Henry law gives information about the solubility of gas in liquid. Learning outcomes from this session is you will be able to learn about Henry law and its practical application. So we can see from this picture that carbonated drinks, when you open it, it gives fizz sound. We will be able to know the answer for this question after listening to this video. So let us say solubility. Solubility, what is solubility? Solubility, if we take salt in water, which is a liquid, solubility normally increases with temperature, but it is not applicable for all the substances. Generally, those reactions are endothermic, solubility increases with temperature, and those reactions are exothermic, solubility decreases with temperature. It means delta H positive, solubility directly proportional to temperature, and if delta H is negative, solubility inversely proportional to temperature. So next part is solubility in liquids, gas in liquids. So generally solubility, when you increase the temperature, solubility decreases, and if we are increasing the pressure, what happens? If you are increasing the pressure, solubility increases. So this statement is Henry law. Amount of gas that is dissolved in a liquid is directly proportional to the pressure of the gas above the liquid when the temperature is kept constant. So we need to keep the temperature constant because KH is a function of temperature and P is partial pressure of the gas above the liquid, X is the mole fraction of that gas, and KH is Henry constant. And if we talk of practical applications, there are three practical applications which are more prevalent. That is carbonated soft drinks. When we take Coca-Cola bottle, when you open, it gives fizz sound. Why? Because the gas is stored in high pressure. When you are opening, atmosphere pressure is 1 atmosphere, the pressure is decreasing. So the pressure is decreasing, the solubility of carbon dioxide gas is decreasing as per Henry law. So therefore, carbonated drinks, when you open, it gives fizz sound because carbon dioxide is going out. It's coming out. So therefore, the solubility decreases with pressure. Pressure decreasing, solubility decreases. Second condition is bends. It is applicable for divers when they go deep down into the ocean. The pressure of the atmosphere, that is atmospheric pressure, plus the pressure of the hydrostatic water, the water present over the diver. So that when pressure is increasing, the solubility of gas other than oxygen also increasing. For example, nitrogen. So the nitrogen solubility increases when the diver inhale the gas which is in the cylinder. It may contain little amount of nitrogen as well. So the nitrogen will be dissolved in the bloodstream. So when the diver will come back, the pressure is decreasing. There will be formation of the vapors will be formed for that gas which is soluble, that is nitrogen. So which leads to a painful condition and sometimes may lead to death also. So that is known as bends. So nowadays we are mixing helium gas along with oxygen to prevent these type of untoward incident. Anoxia, that is also known as altitude sickness. When you go to higher altitude, the pressure is less, atmospheric pressure is less, thereby density of oxygen is less. You know, pressure is directly proportional to density of the gas, and thereby people feel difficulty in breathing. That condition is known as anoxia. So now let us take up one numerical. This numerical is a basic numerical but it contains two components. Henry law constant for carbon dioxide in water is 1.67 10 per 8 Pascal at 298 Kelvin. Calculate the mole fraction of CO2 and mole fraction of gas in 500 ml of soda water when packed under 2.53 10 per 5 Pascal at the same temperature. Temperature is constant. KH is function of temperature, we know. So now in this problem, one is mole fraction calculation, that is very easy. P is equal to KHX. But the second question is moles of the gas. So first you will calculate mole fraction, then you will apply formula moles of carbon dioxide divided by total moles. So we can solve. For example, you have been given KH, we have been given P, pressure, mole fraction we can find by using the formula P is equal to KHX. We can solve it, and X is not having any units. But when it comes to the mass of the gas or moles of the gas, you have to apply the formula mole fraction of carbon dioxide is equal to moles of carbon dioxide divided by total moles. And here in the denominator, because moles of carbon dioxide is very less, we can make it 0 in the denominator, and moles of water we are taking as, because volume was given 500 ml and density of water is 1 gram per ml, so mass is 500 gram. So if you want to calculate moles, mass divided by molecular mass 500 by 18. So thereby we are solving this moles of carbon dioxide, which comes out to 0.042 moles of carbon dioxide. So next is conditions. So Henry law is not that it is applicable for every condition. It is applicable when the molecules are in equilibrium, liquid vapor equilibrium. Second point is pressure should be low, means ideal. If pressure is high, the gas will change into liquid. So this law will not be applicable. So that will be real gas. We are talking of ideal gas. Okay. So next part is there is no reaction between solute and solvent. So some gases like HCl water reacts to form hydronium and chloride ion. Similarly, ammonia plus water. So there this will not be applicable in this way. So now Henry constant depends on what factor? Already we discussed that it depends on temperature. More is the temperature, more is the value of Henry constant. And please note that higher the value of KH, that is Henry constant, lower is the solubility of gas. And Henry constant also depends on the type of gas. If you see from the graph here, so oxygen, nitrogen, helium. So this gases more solubility is with for oxygen. So I am hopeful that you have got the answer now why carbonated drink gives this sound. And whenever you are writing these answers, please do mention Henry law. The solubility of the gas is directly proportional to the pressure of the applied gas is directly proportional to mole fraction of the gas dissolved. P is equal to KHX. Expression also we can write. So at the end, recap, we have done Henry law, which is P is equal to KHX. And practical application, 3 practical applications we have discussed: anoxia, bands and carbonated soft drinks. And conditions also, that is ideal condition and reaction should not be there. Okay. And numericals we have done on the basis of P is equal to KHX. So that's all for today, and thank you for watching this video. So please do download the app, share the video, and if you want more questions to be solved, please download the app and attempt the test. Thank you.